Hello, everybody. Welcome to our next talk at PyData Global. We are so happy to have you here, and I'm very excited for our next talk. Next talk is by Agustin Nazar, and the talk is titled Enhancing Marketplace Competitiveness, a Bayesian Approach to Modeling the Cold Start Problem. August is a senior data analyst at Get Your Guide, where he specializes in using data to identify customer and marketplace needs that could be solved at scale with data products. His work encompasses identifying customer problems, designing experimentation frameworks and to measure progress, developing analytical solutions, and translating business requirements into data science projects. And beyond his core responsibilities, August is passionate about storytelling, teaching, singing, and almost anything on stage. So with that, let's hand it over.
Yeah. Hi, everyone. Thanks, Jim, for the introduction. So as said, this is me. I work as a data analyst at Get Your Guide. And today I want to talk about this. So you may be wondering why am I showing this slide? And the reason is because at Get Your Guide, we have this tradition to start with a little look back into our last vacation. Get Your Guide is a marketplace for activities that you can do while traveling. And basically, it's a marketplace to find unforgettable experiences. This is in Thailand. I had a great time during this cooking class. And what I want to take you on is that this great activity in which my wife and I can be seen cooking was at some point something more or less like this. Not exactly this one, but more or less like this. So it had no reviews, no bookings, no past. Because I work in ranking and we have this problem, or we say, how do we even model the beginning of these activities? Then this is what I want to discuss today. My goal for today is that you can identify a Bayesian problem at your company and that you can navigate through the messiness of real world data, right? This is my goal. If we accomplish this, then I'm done. There is of course a bit of structure. I'm gonna cover the business problem, the modeling choice, the Bayesian binomial approach we developed, some notes on implementing this at scale, and then last but not least, hopefully space for open questions. Let's go into the business problem that we had in our hands. To Get Your Guide, we have 35,000 suppliers. So we have this, again, this experiences you can do while traveling marketplace. And we have suppliers who offer those experiences. So like me cooking on the right, and 35K of them, 150,000 activities across 12K cities worldwide. What is a problem is that those experiences are personal and are very hard to compare, right? So imagine you have this cooking class on the right. Imagine you may get the ingredients like the picture above or like the picture at the bottom. Those are two completely different things for you. And what you got out of the experience is very different. Even if the activity takes place at the same spot with the same cook and the same people helping you out. So this means that it's very, very hard to tell that activity A and that activity B is different. It's hard to extrapolate, right? And building upon that, it's hard to extrapolate. And what happens when an activity is new, right? So imagine that you are the ranker system for a second, right? You're going to Cancun, lucky you have this grid of 8 activities, and you have an activity that is a promising speedboat tour that you know nothing about it, and you have some activities that you need to choose between the two, right? So a new tour or an average tour that it's average. It may not be great, but it's average, right? And then the question is, how do you even place? Where do you even put this new activity, right? And here we see, right? So I'm new. This is the one I'm talking about. And the reason why this is tricky is because if you never explore, you may get stuck. So let's move here on to the next. if you don't give new experiences, new activities in the marketplace a shot, how do you learn about them, right? So this boat tour can be great or it can be disastrous, but if you don't give exposure, how do you even know? And the dilemma is that the new activities and the new experiences and the existing experiences compete for the same space. So we only have here, let's say, 8 slots, and we need to define what goes where. And where, if I show an activity in this position number 3, that is the new one, then I am not showing another one that I may know the performance of. So I hope by now you get a the gist of like what the problem here is. How can we learn about new experiences performance intelligently? This was the question that I asked myself and that I want to cover today. And what does even if intelligently means? This means that I am efficient in terms of impressions, right? So that I get this exposure and that with as little as exposure as I can learn about the performance while I enable travelers to find unforgettable experiences. So you can up rank this, put it all the way to the top. You will get exposure. But then if you're breaking the experience for someone, remember people come to us when they go on holidays. You don't want that to happen. So you need to balance the two things, like being efficient in terms of impressions and generating insights while enabling always travelers to find unforgettable experiences. I hope so far so good. Please, if not, put a question in the chat. I want to ask you or reflect on what a model is. So what do you think is a model? 3, 2, 1. Right. The definition that I like the most is it is a representation and simplification of reality, right? So it's how we choose to see the world. It's some lenses that we put on. We know that we are leaving some details behind. Um, we leave some stuff aside, but this allows us to also make some predictions on how the world works. And then it's important that we know, okay, this is how I see reality. I know it's not perfect, but it's a way to see it. And based on that, I can make predictions and I can see if I do A, then B is going to happen or not, and so on. This is important because if we know that the model is not perfect and if the model doesn't fit reality, please do not think like this, but rather more like this, right? If the model doesn't fit reality, the model is wrong. This is very important whenever you're picking a model that you keep this in mind, and that sometimes you need to drop your ego on where you started and go from scratch again. The reason why I'm talking about this is because I'm going to talk about modeling choice now for my cold start problem and what I navigated, which is using an ML model or using stats to help me understand the performance of the new activities on our marketplace. Yeah, Thomas. Yeah, almost are wrong. Some are useful. That's a good one. One thing more important than trying predict is framing your problem the right way. Again, going back to the problem, which is like, how can we learn about the new experiences performance intelligently? We had this family of ML models which can predict, right, or can classify. I can predict given 10 impressions how many bookings you'll get, or if you'll get to n bookings given 10 impressions, or so on and so forth. You can predict or classify. And when I came up with this, then a colleague comes up to me and he says, hey, like what you're doing, actually, I appreciate your thinking, but I believe your problem is you're solving the wrong problem. It's like, what do you even mean? It's like we have this new activities and we just want to know what the performance will be when they're starting off. Like, what is wrong about that? And basically, his point was like, you're not focused on predicting or classifying things. What you want to know is, or where you're starting off from is, you don't know about the activity and you want to model this uncertainty and you want to chop this down over time as you gather more traffic. So on the surface, they may look like very similar problems, but on the one hand, you say, okay, it's theoretically possible to predict how many bookings you're gonna get, given any impressions, or classify this. Whereas on the other hand, you would say, I don't know about you. I'm gonna get more information about you as we go. And I can quantify this uncertainty, which is how much I don't know about you, and see it hopefully drop over time. So it may not look very different, but actually, in fact, it is exactly like this. Um, for us, again, like you can go into more theoretical discussions, but what I've learned is that machine learning and Bayesian stats have usually very different goals, right? So machine learning is better suited for when the outcome depends on the attributes of the predicted item. So if there is a way of saying, hey, based on XYZ, like is this experience great, or will it get bookings and so on and so forth. So I have some attributes that I can use to predict something. Whereas Bayesian statistics is more about I have a starting point based on previous knowledge and maybe activities that I deem somewhat similar, they behave in a specific way, and then I model this uncertainty over time as I gather more and more information. The reason why I'm calling this out is because how the organization you're working sees the problem influences you. So it's very important that you're intentional about this, right? If you say this is a machine learning problem, then if you fail, then it means, hey, this is solvable via data science. We need to predict a fewer outcome and let's build a model to solve this. And if it doesn't work, let's build a better model, right? And we believe this is the right way to solve this. Whereas if we say, hey, we don't know and we do not assume that there is a way to, based on the attributes, understand if this is gonna be successful or not, if this experience will be successful or not. So let's start from I don't know, let's gather information on the way, and then we see how this develops, right? And then if we fail at this and it's okay, like maybe we're starting from the wrong place, or maybe we don't have the the right information, or when we don't have enough information, but we are assuming starting that we know nothing. And this starting point really shifts the conversation. Um, to me, if I could go talk back to my, if I could go back to my younger self, I would say like spend good time defining the questions that you want to answer and finding the right approach. So in the first place, I got very excited about like deploying models and using trees, and then like stuff that was more complex to try to predict censorship, not entirely, but yeah, in the direction it goes. I'll cover that in the presentation. But basically, understand what's the question is, and spend a lot of time on that, maybe even more than you would think. Going on the Bayesian binomial approach itself, a binomial, I cover what binomial is, what Bayesian is, and then how we put things together, right? So this binomial distribution is useful when you have a trials with a binary outcome, pass or fail. So let's say this picture on the left, I have like this 4 activity cards, and I see all of them, and I may click or may not click on them. So it's like you have like 4 trials, and then may or may not click to determining the success. You can see it here in the example, right? So let's say that this is my trial, this is my success. And there are a few assumptions. One is like that each impression is independent and that there's like constant probability of success. So if you do this on an activity level, then ideally you say, okay, I gather information. Every time that I show you, you get click or you don't. And there's one thing here to call out, which is that sometimes assumptions will break, right? In our case, we know that when there are reviews, these reviews may affect the clicking behavior, right? So imagine you do not have any reviews, and then all of a sudden you have, then this may change how people click on your activity. So what I want to say with this is be wary of when the assumptions break. In every model, you will need to make some assumptions. No model will be perfect. Define and be very intentional about like when you want to flex and when you don't with these assumptions. And the constant probability of success, then the same, right? Like you may say, okay, I show this in places that I deem that are similar on my platform or marketplace, so then the probability of success is somewhat similar for an activity. You may say no when this is shown on the click-through rate in a specific swim lane is very different than in any other place, and you want to separate those two cases, this is also fine. But again, it's stuff that you need to check when you're modeling things in a certain way, just so that you can draw the right conclusions. So that was on the binomial side. And then like the Bayesian approach, right? And the Bayesian approach allows for regular updates to the binomial distribution. I will make a very easy example about this. Let's imagine for a second that I'm going to a new city, right? So trials, or I'm in my city, I'm here in Berlin. So I'm going to my favorite restaurant. Those are my trials and successes that I leave happy, right? I would expect this ratio to be close to the rating of the restaurant. This is one of my favorite places here. What I see first on my phone, right? I check, open up on Google Maps, and like this is what I see. I think that this is awesome. But then actually I may read the reviews and I update my expectations. And then I say, okay, this place is great, but actually there's long lines. And then if I'm in a hurry, then this wouldn't be such a great fit. So I update this 4.9 to something else, depending on how much time I have on that day. But what I want to say with this is that we do this all the time. So we know something, then we get more information, and when we update like our belief on something, you can see the chart on the right. Again, with restaurants, I think it's a good way of putting it and showing how our brain does this. And then if our brain does this, and if we operate that way, then why shouldn't models operate that way, right? And again, the Bayesian approach is just a way to enable this to happen. When it comes to your question, Tomasz, on it sounds like a decision based on the risk appetite. On the one hand, yes, but the most important thing here is that we model the uncertainty. So we model what we do not know, right? And then we will be able to say, okay, what we didn't know was this big, and now what we don't know is this big. Am I okay with this? Yes, no. So there is a component of risk, but also important is I knew that it was like this, and now I know it's closer to this, right? So like you chop down the risk as you collect more info over time. That said, defining the metric you want to optimize for the weight of the prior, which is how important prior history is for you to your model, and the stopping criteria. So this means when do you say, hey, I have enough information, I'm fine. This is a context dependent call, and it's important that you know that. So on the right hand side, you see a chart of a performance of an activity that you have those confidence intervals, right? And then at some point when the background turns green, it means that, hey, the confidence interval is narrower than the threshold. So I believe I know enough about this, I can stop. But again, like this is what you expect to see. You start with a very wide confidence interval and it narrows down over time. How much narrow is good enough? Depends on your context. To me, the most important thing is that, again, you ask yourself those questions. So what's a trial? What's a success? How important is the prior knowledge? And also, how much certainty are you okay with? And again, of course, like as we said, that if there are certain assumptions in your model, just go check if those assumptions hold, yes or no, and up to what extent do you want to flex with that. The other part is defining the stopping criteria, which you can do, I would say, mostly in two ways. So you can define the confidence interval width and say, I gather information for my binomial model. I update this in a Bayesian fashion over time. And then when my confidence interval is narrower than, let's say, plus minus 10%, then I believe, okay, I'm fine, or 1% or whatever. Or you can also say, based on the value of incoming information, which means that, hey, if time goes by, let's say I collect information for a week and my confidence interval doesn't really move, then this means that even though I get more traffic or more information, this is not adding anything new to me. So this is not adding any knowledge to me. So I can say, okay, the value of the incoming information is very little, so I can stop. Or you can just, again, take a combination of both, which is also fine. But this shifts your conversation from, hey, I can predict if an activity is going to be successful or not, to say, I can model how much I know and I don't know about this. And also, I will determine what is enough or what's not enough, depending on my confidence interval or the value of incoming information, which is exactly what we say. Then, some last notes on how I implemented this at scale. Basically, a very, very simplified overview, but good enough for this, on how we generate and collect data. We have some visitors, they browse Get Your Guide, we collect some events, and we calculate daily stats per experience. So this is how it looked like at the moment I started this work. So then what I said was, okay, given the fact that I have all of this, I have this daily stat, let's aggregate those, let's apply the Bayesian statistics, and then output the results into a table. So the first part occurs in S3 and Airflow, dbt, and then the rest is all of that on Databricks. And it's important that you identify like where you're starting from, and basically what can you leverage already, so you don't reinvent the wheel. In my case, leveraging the PySpark's UDFs and SciPy was the most efficient way of implementing this at scale, right? So there you can see on the right, it's very, very simple. Again, like considering that I have the experience level pre-aggregated data, so someone else was doing the heavy lifting for me and querying the events table, that each row is independent of each other because I have data on an experience level, so this is already fine. And that PySpark and Databricks, like that, this environment allows for distributed computing. This was the best way to do this, and simple and elegant, which I really liked. And again, we're just now getting into the end of this. But one thing that I realized at the very end, and that I would have saved me time too, was to put into question if you need the evolution or the end state when you're doing this kind of work, right? So when you're building and understanding this new approach, when you're backfilling and understanding things and how history would have been, and you're recreating history, and I'm sure many of us actually have been there in one way or the other, you may need the evolution day by day of your system. But actually, when you're deciding whether to stop or continue gathering information, you don't care about the rest. You only care about day n, right? This taught me mostly two things, or one thing, that sometimes dev at scale is not prod, right? So be very mindful of, okay, what will I really need to make a decision when I'm in production, and do I need all of these intermediate steps? Maybe not. And if you don't, then you're gonna save yourself a lot of time and complexity, right? Yeah. Not only this reduced runtime and credits and complexity, but also this made it easier for other people to understand the code, which is in every case, yeah, just better. Yeah, my three key takeaways of this is that getting the problem right, which is what I spent most of my time talking about, can be much harder than building the solution. It's like we're wired in a certain way, we work surrounded by people, we see problems in a certain way, and identifying the right problem can be tough. So do not underestimate that. Then the development may be more complex than what you need in production. So again, like, you may be very excited about that and say, okay, like I have this and now I need to find a way to make it scale. Maybe you don't, and actually it may feel like, okay, then what I've done is too simple. That's better than building a complex system and then needing to maintain it if it does the job. And then beware of when your assumptions don't hold anymore. So what I mentioned about those reviews, and when you get a review, then the clicking behavior changes. It's like you will need to make a judgment call, because again, no model will be perfect. So recommendations for users are there by sorting via the calculated stats, right? I can take that in a second. But yeah, be very, very mindful of that. I remember, especially with like when you're breaking some assumptions, that this means great power, and this also means great responsibility for you. I hope that by now you can identify a Bayesian problem at your company, that you can differentiate between this, I need to predict how this would work, versus I need to model uncertainty, and that this helps you navigate through the messiness of real world data. If you're interested, if you want to learn more, please learn about what we do. You can see our blog posts there, scanning the QR code. You can reach out to me. You can send me an email, LinkedIn. Yeah, I'll be happy to help you out. So yeah, thank you so much. Now I'll move on to the questions. Yes. So yeah, Thomas mentioned that this is like the decision is based on the risk appetite, and Aro mentions if the recommendations for users are derived by sorting via the calculated stats. So our problem was to say what is the performance of a new activity, and if we have enough data for that or not. And then the output is a table in which we say this activity has this confidence interval for the performance metric. So it's not that I'm recommending something to users. It's not a ranking algorithm, but rather showing, hey, this is the performance of the confidence intervals for this new activity. If I've used SignPy optimize any other type of function for sampling from the posterior, no, I did not, but I think that would be something cool to check out. So thanks for the suggestion. No, today I did not.
Thank you. We are just about at time here. If anyone has any other questions, you can go over to the Discord page and ask there. And then the recording of this will be up for replay soon. So we
Nice.
appreciate it. Thanks for your time.
Cool. Thank you very much.
Yeah. Have a great day, everyone.
Thank you. Have a great
Bye.
day, everyone. Bye.